Great. Thank you, Dave. So I'm Chad Mason, founder and CEO of Advanced Ionics. So today I'll be talking about industrial transformation through clean hydrogen. So you may or may not already know that hydrogen's used everywhere in just about everything you can imagine. Plastics, metals, glass, fertilizers. There'll be a $200 billion industry by the year 2023 and over $1 trillion by 2050. However, hydrogen is currently produced from fossil fuels and delivered via truck. It's a cumbersome, polluting, and wasteful process. So if hydrogen were its own country, it ranks 6th in emissions, actually ahead of Germany. So pretty massive. So we'll be changing the paradigm using just clean electricity and water in systems called electrolyzers. So why isn't this being done now? I mean, electrolyzers have been around for over 100 years. Well, they weren't considered cost effective. They were usually attached to hydroelectric projects with free electricity. So they were never designed specifically for widespread industrial use, whereas natural gas, steam methane reforming was. And the cost of hydrogen from electrolysis is 3x of that of methane reformation. But do note, 85% of the overall cost is just OpEx, which is electricity used. So use less electricity, you get a lot cheaper hydrogen. So let's look at the two main processes that use hydrogen on the planet. 90% of all of it goes into fertilizer, specifically ammonia, and refinery operations. And they're hot. They run anywhere from 150 to 600 degrees Celsius. So if you want to make electrolysis as efficient as possible, you need to operate it at those temperatures. Unfortunately, existing electrolyzers can't do that. They operate too cold. Other technologies like solid oxide are too hot. They don't function when you get them in 200 to 600 degree range. So we're designing systems that'll operate in the sweet spot, enabling the lowest possible electricity use. And what this will result in is electrolyzers that for the first time can actually compete with low-cost steam methane reformation using natural gas to make hydrogen. And this doesn't even require carbon pricing or carbon taxes like what's talked about. So at that point, we change the paradigm and clean green hydrogen becomes the default hydrogen source for most projects worldwide. So how do we do that? Well, it starts with a patented electrode architecture, which you can see on the left. That goes into a cell, which goes into a system. You can also see some of our prototyping work there. And that results in 42% average lower cost than incumbent technologies. So where would you ideally put an advanced ionics electrolyzer? Because it's very important. Well, like I discussed, you need to have process heat on site. So any place you can make steam, you can use our electrolyzer and make cheap hydrogen. So refineries, metal factories, nuclear power plants, geothermal power plants, other things like that. So it can be used for its on-site processes or for exporting things like chemicals, ammonia, or for even other regional processes, grid backup, data centers, long-haul trucks, ships, and airplanes. So that's basically our target markets also. The biggest example, just in the US alone, is there's a $3 billion per year sales potential for us. And that's another $1 billion for ammonia and about another $500 million for metallurgy, just North America. So our fundraise, we closed the biggest part of our deal 2 days ago with Clean Energy Ventures out of Boston. There's 235K remaining now. So if you're interested, please email me pretty quickly because we'll close all that out, I'm guessing pretty soon. And this funding will be used to capitalize on our early progress. We have targeted milestones we have to hit that'll trigger an automatic seed round. We'll be working towards pilot scale project development here with potential customers in the coming year, trying to sign up an MOU or LOI with at least one or two. and funding 12 to 15 months of operation. So a little bit about our finances. Beyond year 3, we'll be in the black and in an excellent position to exit by year 5 or 6. So a little bit about exits in our industry lately. It's starting to really heat up most recently with Nell acquiring Proton, Plug acquiring Geiner quite recently. The big one was Cummins acquiring Hydrogenics for $290 million last year. So just as a quick example, you know, an investor could expect an 11 to 21x return on a $200 million exit if they came in now. So a little bit about our team. I'm Chad. I'm from the state of North Dakota. Been a little bit all over the place, working on fuel cells, on lithium and sodium ion batteries, other electrochemical technologies, most recently at General Motors on their fuel cell durability team. My colleague Bill was most recently one of the subject matter experts at Johnson Controls, has been and has a PhD from Texas Austin. Ted just joined the team recently to develop, do market analysis and customer development and further customer discovery. We have some pretty awesome part-time people and advisors. Nick, who did his degree at Booth, was at Exelon for a while in Purdue. John, who's also associated with Clean Energy Ventures, and Damien down in Chicago, and Dr. Salman down at IIT in Chicago on the scientific side. So we're based out of Milwaukee. We're hosted at the Midwest Energy Research Consortium, and we lease from them. So we have a really awesome ecosystem here in Milwaukee and in the Midwest in general. And we're bringing on some pretty awesome partners here already. So looking forward to talking to you folks more.
Great, thanks, Chad.